Today we're going to talk about compositions of functions, which we actually have already done before, but now we're going to kind of tie everything together with domain and how the new complex fractions that we've been talking about. But you guys remember seeing this notation, right?
Yeah.
F of g of x is how you read it. This is one way to write it out. You could also just write it as f of g of x. This part right here is important. The domain of the composition is a set of all real numbers x that are in the domain of g, such that the whole function is in the domain of f. It's kind of wordy, but we'll do some domain examples later, okay? The main idea, you guys, when you're finding domain for compositions is once you plug functions in, before you start simplifying and seeing what it equals, find the domain. It's kind of like with the rational, the fraction graphs that we did. Remember how sometimes those factors canceled out?
Yeah.
But we said it's still part of the domain or not part of the domain, right? So before we simplify, we want to find the domain. That's the key here. Okay, but just to review, probably the easiest way to do these, since we're looking for just values here, is to not actually, plug g into f, but just take 1, and first I figure out g of 1, right? So if I do g of 1, what is that going to be? 4. And so now I do f of 4. So I take 4, plug it into f. So it'll be 2 times 4 squared minus 3. So what is that going to be? 32 minus 3, 29. Okay. Does that make sense, you guys? Do I need to do the other 3 examples, or can we move on? You guys remember doing these, right?
Yes.
Okay. So if you forget, write it out as f of g of 1. Figure out the inside first. Once you have that answer, plug it into f. You're done. And if it's reversed, like g of f, same idea, right? F of f looks kind of silly, but it's the same idea. Actually, let's do this one. I don't think we've seen many of these, okay? You write it as f of negative 2. So you're going to take negative 2 and plug it into 2x squared minus 3, right?
Yes.
So that's going to be, I'm going to just figure it out off to the side here. 2, I think somebody already said the answer. What is it? 5. And now once I have that answer, I plug it again back into f. So that'll be 2 times 5 squared. That's going to be 50 minus 3, 47. You guys okay with that, right? Okay. Oh, I guess we should have done do be real quick because we need to answer this question. What did you guys get? Negative 4? Okay. Do you guys know what commutative means? Okay. Commutative is a fancy way of saying that the order in which you do things doesn't matter. You still get the same thing. For example, 2 plus 3 is the same as 3 plus 2. That's an example of the commutative property of addition. Multiplication, 2 times 3, 3 times 2, same thing. We say multiplication is commutative. Compositions, though, do you see how we're doing f of g of 1 and then reversing it?
Yes.
Is not commutative necessarily. Here's a perfect example. One way we got 29, the other way we got negative 4. Does that make sense? Okay. All right, let's talk about example 2 real quick. Here we don't have a function, we have a table. I love these because these are actually a lot easier than the functions. Okay? First, we write this as f of g of 1, right? What is g of 1? One represents the x, so we plug it in and we get 0. Does that make sense? And now to find f of 0, you go to 0 on the table and find the output for f, so that's 2. Does that make sense? Take 15 seconds, figure out the other 3. These are quick, right? What were your answers? -3 for the first one, 6 for the second one, and 6 again for the last one. Is that what everybody got?
Yeah.
Well, now don't you hope you have like 30 of these on Math Excel? You just cruise. You're not going to have that many. But if you see some of the homework assignments on Math Excel that look kind of lengthy, they're actually not too lengthy. It's some of the problems are literally, very quick. So just don't get alarmed and go, oh my gosh, this is going to take me 3 hours. It shouldn't, okay? All right, next page. Same thing, but now we're looking at a picture. Same concept, though. Does this make sense?
Yes.
Okay. F of g of 1. So to find g of 1, first I go to 1 on the x-axis, right? And now which one of these graphs, the parabola, the cubic, or the line, is g? The line. So at 1, where is this line? -3. So that is the answer for g of 1. Now I repeat the process. Go to -3 on the x-axis and find f. Where's f? That is correct. It is at 0. Does that make sense, you guys?
Yeah.
Okay. Try these 3 again real quick. Take a minute. Let's make sure we got them. What's that? Oh, you're right. It's kind of cut off. Yeah, let's go with 12. That's fine. It probably is 13 to be honest, but that's okay. Okay. With the exception of B, this one's kind of weird because I think the parabola is just a little off from what it actually should be. So it looks like it's getting close to 12. You could even argue that it maybe is 13 for your final answer. Don't worry so much about that one if that's kind of weird because it's a little off. But you should have gotten 2 for C and -6 for D. Make sense? For this one? So h of 1, 1h is at 5. So now I do 5 And it looks like we're at -6 right here. Does that make sense?
So you look at the x-axis and then you do what your point is.
The output, yeah, exactly. Anything else? Okay. So let's start talking about the domains now. And now you're going to start to see what we learned yesterday. Here we have h of j of x. Okay. Let's go ahead and just figure out what h of j of x looks like anyway to start. Okay. So h of j of x means I'm going to take all of j of x. And now where does that get plugged into? Into the x here for h. Does that make sense?
Yes.
Instead of having a single number, we're plugging in the entire function into this x value. And so now this is going to look like 1 over, instead of x, we're replacing it with 4 over x minus 1 plus 2. Okay? So now, obviously, we can clean this up, right? We talked about how to clean these things up yesterday. But before you do that, that's when you find the domain. Okay, so that's the key here, is find the domain first. Then simplify. Okay, and you know enough to figure it out. We have a fraction, right? What are the rules for dividing? What can we never have in the denominator? We can never have 0. So one thing that we cannot have is the entire, you see what I'm saying here? The entire denominator can never equal 0. Okay? Let's figure out what x value that is, just from this part. How do I solve for x? What can I do? Subtract 2. Okay? I'm going to just squeeze it in right here. 4 over x minus 1 is now going to equal, not equal, thank you, -2. And then multiply by the x minus 1. So now we get 4 cannot equal -2x plus 2. Subtract 2. So now we get 2 cannot equal -2x, so x cannot equal -1. Okay, so there's one of the x values that does not work. Do you see any other denominators that could present problems for us besides this large one? This little one right here. This also can never equal 0, right? So if x minus 1 cannot equal 0, what's the other value for x? Cannot equal 1. So for this problem, the domain is both x not equal to positive and -1. Okay? Do you guys kind of see how we figure that out? Before you simplify, we're going to find the domain. Okay? Now, question? You sure? Okay. Now that we know what the domain is, we're going to go ahead and find the composition now. So going back to this part in green, this is what we did yesterday. That's why we kind of reviewed this stuff. How do I simplify this? Multiply by x minus 1. So now, I'm just going to not do b, by the way. When I multiply by x minus 1, our numerator is x minus 1. The x minus 1's cancel from the first fraction, so it's just a 4 left over, plus 2 times x minus 1. Okay, and now we can simplify. x minus 1 over, this is really 2x minus 2, so we can combine those, right? 2x plus 2. And there's our final simplified answer. I think sometimes on Math Excel they might ask you to write in factored form. I don't know if you've seen that.
Yeah.
Just factor it then. What can we do here to factor? Take out a 2. You guys know how to do that at this point, okay? I'm telling you though, for our class, if you leave your answer like this and nothing cancels out and you decide I'm not going to factor it and waste the time, that's fine. I don't really care that you do that. However, if this up here were an x plus 1 and it does help you to factor and cancel something out, you need to make sure that you're doing that, okay?
Yes.
All right. Let's try one more composition. Instead of doing fractions though, let's do C. Okay? Why don't you guys try this one on your own first? Okay? See if you can find the domain and find the composition. I'll give you a minute or two here, and then I'll go over it.
Before you do that.
Did you guys get this far? Did you see what it, right? G is going to get plugged into F. So this is the first step. Okay? What do we do now? Before we simplify, find the domain. And you're going to see why in a second. Okay? Let's simplify. Let's find the domain. I just said we're going to find the domain. We have, before we square, we have a square root here. What do we know about radicals? Do you remember that's the other one that we have to be careful with? This has to be greater or equal to 0, right? You cannot square root any numbers that are negative. So that's what we start with. So that means that x has to be greater than or equal to 1. This is the domain. Okay, very important. I'm going to show you a picture here in a minute that will, for those of you that are visual people, kind of hopefully paint a picture as to why we need to do the domain when we do it. Now, can we clean this up? Of course. Jordy, you were saying just take the radical out, so we get x minus 1 plus 1, which is x. So this is my answer when we, simplify it. But do you see if you wait until the end to find the domain, you wouldn't find it right because you would say, oh, it's all real numbers. There's no division, there's no radicals, there's no issues, right? Let me show you. Maybe you don't know how to do this in the calculator, so if you want to follow along, it's not a bad idea. If you want to go ahead and just take a second and type in x squared plus 1 into y1, and then for g, type that into y2, okay? And let's just set it up that way. Oop, hold on. I got to switch my mode here. Ah. Okay, so I'm going to type in F, type in G, okay. Now, instead of using F and G, how would I write this on the calculator? Instead of F of G of X, what am I doing then? Using y's, what would it be? y1 of y2 of x. Do you guys see what I'm saying?
Yeah.
On the calculator, f is really y1 and g is really y2. So for y3, okay, I'm going to type in not f of g of x, but I'm going to type in y1 of y2 of x. And here's how we do that. If you go to vars, that's one of the buttons that we've learned this year, right? Over to y variables. You guys with me so far? First option, function. All of these functions pop up. Okay, so I'm going to hit enter on y1. And now it's telling me y3 is y1, but I don't want that. I want y1 of, so now what do? Back to that same menu. Y variables, function, y2 of x. Very good. Okay, and this is actually a really nice technique to use if you're doing problems where you have to evaluate a whole bunch of things. Maybe you don't want to actually figure them out by hand. Because now, this is pretty cool. If you go to table, let me start it at 0. Okay, if you go to table, now you can do this, if I said what's f of g of 2, you can figure it out using the table if you want. Okay, but more importantly, if you look at the graph, there's f, there's g, and there's our composition. It's not the entire line y equals x. Where is it starting? At 1, which is exactly what we said the domain was. If you look at the table, there should be errors everywhere before 1. That was the first value that worked for the composition. Okay? Make sense? Okay. So, to summarize, make sure you find the domain. After you plug everything in, find the domain, then clean it up and simplify it. Okay? All right. Let's turn the page. We only have this last page to do, so we should be able to get it done. Here we're showing that if I plug m into k, or if I plug k into m, no matter which way I do it, that the answer should be x. So this is really just an exercise showing the algebra and showing that both times, no matter which way you do it, you get x. Okay, so let's do that. K of m, I don't know why I wrote f. This means k of, now what's m? M is 1/2 times x plus 6. And so now this gets plugged into the k function for x. So what would I write? 2, and instead of x, 1/2 x plus 6, and then don't forget the minus 6. Do you guys see what I'm saying here? this pink X is now replaced with that, because that's what we're plugging in. Okay? We can simplify. What's 2 times a half? So this becomes X plus 6 minus 6, which is X. Okay, these are kind of nice because we know what the answer needs to be. If you're not getting X, then you know that you messed up somewhere. Okay, and now we just do it the other way. So if we do M of K of X, K is 2X minus 6. And so now 2X minus 6 gets plugged into here, so we're going to have 1/2 parentheses 2x minus 6 plus 6. So this little guy here, this x, got replaced with that, because that's what we're plugging into it. Does that make sense? I know it gets kind of overwhelming sometimes with all the parentheses, but if you think of x as your input and that you're allowed to input functions, numbers, it doesn't make a difference, then this should be all right. Okay. Here, following the order of operations, I could kind of simplify the inside first, right? 2x minus 6 add 6. What is that? 2x. What's half of 2x? X. Okay, so no matter which way we do it, we get x. Okay, and that's actually very important because we just talked about over here that composite functions generally don't do that, right? You know, remember we talked about commutative? This is the one exception where if you plug one into the other or go the other direction, that you get the same answer. This is what we call an inverse function. We're going to learn about those and talk about those later, but this is important for these functions to be inverses of each other. Okay? Let's go to example 2. Here we're working backwards. We're finding functions, little functions f and g, so that f of g essentially equals this. Okay? So looking at this, do you kind of see an outside function and that maybe something was plugged into it? So we have x squared plus 1, and then that's to the 50th power, right? So one thing that I could do is go this way. So what does g have to be so that I can still get this function? Well, g looks like it's this input. Do you see what I'm saying? So then what does f have to be in order for this to become to the 50th power? Something to the 50th. I like the way you said that. We're going to use x to the 50th. Okay? So x to the 50th is one function. X squared plus 1 is the other function. Do you guys see what's getting plugged into where? X squared plus 1 is getting plugged into here, and that's how we get x squared plus 1 to the 50th power. Okay? So little g should be x squared plus 1, and f is x to the 50th. Maybe this confused you more than it needed to. Ignore that. Okay? Can you guys see that there's two functions basically? There's x squared plus 1 and then something to the 50th. So we're going to have to split it up to figure out what went in where. Okay? Think about this one. What functions do we have? Let's just write them down. X plus 1 is one of the functions, right? And then 1 over x is the other one. How do I make this become that? What order? What's getting plugged into where? This is getting plugged into here. So that means that g is x plus 1 and f is 1 over x. Okay? These get easier as you see them more. They're not meant to be difficult. It's just meant for you to see how to kind of decompose, go backwards, and figure out what pieces there are to create a certain function. Okay? All right. Last problem. I know this has been long. I appreciate your patience. I just would rather give you more time in class to work rather than, do notes really slow. Yes? Yes. All right, read through example 3 real quick. Don't be scared just because there's words. Don't get sleepy just because you're reading.
Shut up. So rude.
Just trying to do my math.
Whatever.
Okay. Look how easy this is going to be. They want equations basically for everything. But let's start with what we know. Do we know the area of a circle? What's the formula for it? Pi r squared. Okay? Actually, that would just go right here. Area of a circle using r as my variable. There it is. That's not hard. Now it says, what's the radius as a function of time t? Well, if you read carefully, it tells you in the problem. Yeah, r of t is 200 root t. And now it says, what's the area of a circle using t's? Well, the area of a circle is pi r, but what is r? 200 root t squared. So there we did a composition in a different application, a different setting. Okay? And so you can clean that up a little bit. 200 squared is what? 40,000. And then you got the pi. Happy Pi Day, by the way.
Yeah.
And then root of t squared is going to be t. So here's your final function. Okay? That was it.
Ooh, that's an L.
Yeah, we're just plugging in what they gave us in the problem for r.